Okay, we want to locate the points on the surface given by y squared equals x times z plus 2 that are closest to the origin. So suppose x, y, z, suppose that point is on the surface. Then the distance between this point on the surface and the origin is given by the distance formula. D equals the square root of x minus 0 squared, which is just x squared, plus y minus 0 squared, plus z minus 0 squared. And to further simplify it, you know that on the surface, y squared is equal to x times z plus 2. So the distance is equal to x squared plus the square, the distance is equal to the square root of x squared plus y is x times z plus 2, y squared is x times z plus 2, plus z squared. Okay. But I can further simplify things by, instead of minimizing this function, I can minimize the square of this function, because the x, y, and z that produce the minimum distance will be the same x, y, z that produce the minimum square of the distance. So I'm going to call that function f of x, z. And you square the distance, the square root disappears, which makes it an easier problem to work with. So you get x squared plus x times z plus 2 plus z squared. To find your critical point, take the partials. The partial with respect to x is 2x plus z. The partial of f with respect to z is x plus 2z. And remember, you set both of these equal to 0 to find your critical point, or points, whatever the case may be. Solve this system. Easy enough. You get z equals negative 2x, and plug that right in there, which gives you x minus 4x equals 0, or negative 3x equals 0, which just means x equals 0. And since z equals negative 2x, z must equal 0. And since on the surface y squared equals x times z plus 2, y squared must equal just 0 plus 2, or just 2. So y squared equals 2, which means y equals plus or minus root 2. So I'm going to argue that the point 0, x equals 0, y equals plus or minus root 2, so there's actually 2 points here, and z equals 0. I'm going to argue that both of these will produce a minimum without bothering to apply the second derivative test here. Why can I do that? Well, it's the nature of the problem. If you think about it, this surface floating around in space is defined for all x, y, and z, so it should make a closest approach to the origin. However, you can get it as far away from the origin as you want. So there's not going to be an x, y, z point on the surface that produces a maximum distance from the origin. But there should be points that produce a minimum distance. So I would argue that these 2 points produce that minimum distance.